So we are going to begin discussing thermodynamics now. So this is the next extension of our kinetics discussion. We're going to begin by discussing heat flow. So to begin, temperature. Temperature we've talked about in the past, okay, when we hit gas laws. One thing that we understand now is that temperature is the average amount of the kinetic energy in a sample. Temperature has to do with the motion energy of the sample. Heat results from the transfer of energy from one substance to another. Okay, so it's really important to understand that temperature and heat are related, but they're not the same thing. If I have something that is 500 Kelvin and it comes in contact with something that is 100 Kelvin, heat will result in this system because there's a flow from one thing to the other. There's a transfer of energy. But this 500 Kelvin sample alone, we wouldn't describe that as having heat. We would say that has a temperature. It has energy, but it is not showing heat. It is not going to be changing or transferring energy. One thing that we have to consider also is that heat always flows from the substance with the highest energy to that of the lowest. So in the sample that I began with here, this example, notice that my arrow goes from the 500 Kelvin to the 100 Kelvin. Heat always works in this way. It's going to go from the highest concentration of energy to the lowest concentration of energy. Okay, so it's going to spread out in that way. Lastly, heat stops flowing once both substances reach the same temperature. So let's say, again, thinking back to this example, I have a 500 Kelvin sample and a 100 Kelvin sample. Well, the 500 Kelvin sample is going to lose energy. It is going to lose temperature. The 100 Kelvin sample is going to be gaining energy, so it is going to gain temperature. And what will eventually happen is they're going to meet somewhere in between these two energy levels as their final temperature. So let's say, for example, they stopped at 190 Kelvin. What we're saying is that for sample 1, I've got an initial temperature of 500 Kelvin, and I would have a final temperature of 190 Kelvin. For the other sample, my 100 Kelvin sample, I have an initial temperature of 100 Kelvin, and I have a final temperature of 190 Kelvin. All you have to be aware of is that these two ending temperatures will be the same. Now I'll give you a second to go ahead and work these practice problems. I will assume that you've paused the video and you've done that, and I can go on. So a piece of metal at 250 Celsius is placed in 20 Celsius water. In which direction would the heat flow? Heat would flow from high to low. So it would go from the metal to the water. Gas in a flask is held at a constant temperature of 25 degrees Celsius. Would you describe the system as having heat? So the key to this problem is it says we have a constant temperature, which means no change. If we don't have a temperature change, then we would not say there is heat. There is no heat in this system. There is energy, right? There is thermal energy, right? We have energy, I should say we have kinetic energy, motion energy, but we don't have heat being expressed here. Number 3, a rock that has been heated to 100 Celsius is placed in a container of ethanol at 0 degrees Celsius to cool. The ethanol heats up to 20 Celsius in the process. What is the final temperature of the rock? So we need to think this through. Rock is heated to 100 Celsius. That is T1 for the rock. It's placed in a container of ethanol at 0 degrees Celsius to cool. This is T1 of ethanol. The ethanol heats to 20 degrees C, so this is T2 of ethanol. So then what is the final temperature? T2 equals what for the rock? Now again, we have to consider that from 100, from 0, energy is going to flow out from here, energy is going to go up from here, and our ending point is going to be 20 for both substances. So the final temperature of the rock is going to be 20 Celsius.